So today I will be continuing my online class on science subject class 9 atoms and molecules.
So we have already discussed in my previous video about atoms and molecules. I have given introduction and about the basic concept of atoms and molecules. So today we will continue with the same chapter, chapter 3 of class 9 science. The main important topics we will discuss today. So first we will discuss about valency. So what is valency? Valency is the ability of an atom to gain electrons or lose electrons in order to attain a stable noble gas configuration. So it is obtained normally by determining the number of electrons in the outermost shell or valence shell. So in order to calculate the valency, we need to know the atomic number and electronic configuration. So for this we can give example of sodium.
So sodium, as we can see, the atomic number of sodium is 11 and the electronic configuration is 2.8.1. So there is one electron in the outermost shell. So before we discuss about this valency, let us talk about uh, electrons. So what are electrons? Electrons, as we can see in the diagram, I have given the diagram here. So electrons are negatively charged subatomic particles which are arranged around the or outside the nucleus of an atom. So how is the arrangement given of electrons? The arrangement of electrons depends upon their potential energies in different orbits. So in this diagram, we can see there are different orbits of sodium atom, for example. So we can see that depending upon their potential energies, there are different energy levels. So the first energy level we can see here, the first energy level, this is K shell, then again the second energy level is, that is the corresponding shell is called L shell. So same way we can see that the third shell is called M shell. So but here the last shell, that is N shell, is absent in sodium. So in this way the different shells are named. So in sodium atom we have calculated the valency to be 1. So this diagram represents the arrangement of electrons in different orbits. Another example we can give of chlorine. The atomic number of chlorine is 17 and the electronic configuration is 2.8.7. So there are 7 electrons in the outermost shell or valence shell. So in order to attain a noble gas configuration or to attain stability, chlorine requires one more electron. So it will acquire one electron from its neighboring element in order to attain an inert gas configuration. And so the valency of chlorine is 1. So we can see that every element or each element tries to attain stability by acquiring noble gas configuration for which it tries to gain electron or donate electron. So next we will discuss about formula formation, how to write chemical formula. So in order to write chemical formula, we need to know about valency of an element. So the first rule, there are 3 rules to write chemical formula. The first rule is to cross multiply the valencies of elements to form the compound. So first example I have given magnesium chloride. In magnesium chloride compound, there are 2 elements, Mg, that is magnesium, and chlorine, Cl. So the valency of Mg magnesium is 2 and the valency of chlorine is 1. So if we cross multiply these 2 elements, the valencies of these 2 elements, if we cross multiply them, then we can write the formula as MgCl2. So in this case, rule 1 is followed. So next we can see again rule 2. In rule 2, what happens? If a compound consists of both metallic as well as non-metallic elements, then the name or symbol of the metal is considered first. So again, in this case also, we have given magnesium chloride example. So here in this case, again, magnesium, Mg is valency is 2 and chlorine is also valency 1. So since metallic elements are considered first, so when we write the chemical formula, Mg, that is a symbol of magnesium, is written first and then chlorine is written in the second. So this way we write the formula of chemicals. So another example also we can give, that is sodium nitrate, which we have given in rule 3. So what happens in rule 3? In this case, if the compounds are formed from polyatomic ions, then the ion is enclosed in a bracket before writing the number to indicate the ratio. And again, we have seen what are these polyatomic ions. So polyatomic ions are ions which contain 2 or more atoms. So the polyatomic ions, if they combine to form compound, then while writing the chemical formula, we have to write the ion in a bracket if there are more than one polyatomic ion. But if there is only one polyatomic ion, then we don't need bracket. So again, we have given example here in case of sodium nitrate. So sodium is valency is 1 and nitrate is again valency 1. So if we cross multiply the valencies of these elements, then we can write them, or we can write the formula as NaNO3. And here in this case, the number of polyatomic ion is 1, and so we don't need a bracket. We will write them directly as NaNO3. Then second, we can see, or we can give example of calcium hydroxide. Calcium is symbol Ca and hydroxide is OH. And what is the charge of, or what is the valency of calcium? Calcium is 2 and hydroxide is 1. So after cross multiplying the valencies, the valency of calcium will go to hydroxide and the valency of hydroxide will go to calcium. And how many hydroxide ions are there? There are 2 hydroxide ions. So because there are more than 1 polyatomic ion, so we will put them inside bracket. So in this way, we can write the formula of calcium hydroxide. Next, we will discuss a very important topic, that is mole concept. Now in a chemical reaction equation, it is more convenient to use quantity of substance in terms of molecules or atoms instead of using their masses. And so a new unit has been formed, which is called mole. So what is a mole? A mole is a unit which represents the number of atoms or molecules or ions. Now if we try to measure the mass of an element, then and the mass of atom of element, then both of them will be equal to 1 mole. That is, what is the mass of an atom of an element? It is 6.022. 6.022 into 10 to the power 23 atoms of the element. So both this atomic mass and mass of the atom, they are equal and both represent 1 mole of element. So 1 mole of any species, that is atoms, molecules or ions, is equal to atomic mass or molecular mass in grams. And as we can see, number of particles, that is atoms, molecules or ions, the number of atoms, molecules or ions in 1 mole is always equal to 6.022 into 10 to the power 23. And this number is known as Avogadro's number or Avogadro's constant. So this 6.022 into 10 to the power 23 is known as Avogadro's number or Avogadro's constant. Now we can see that 1 mole of atom. So what is this 1 mole of atom? It is equal to 6.022 into 10 to the power 23 atoms, and 1 mole of molecule is also equal to 6.022 into 10 to the power 23 molecules. Now next we can see mole of atoms. So what is mole of atoms? 1 mole of atom of an element has a mass equal to the gram atomic mass of the element. For example, we have taken the example of oxygen atom. So 1 mole of oxygen atom is equal to how many grams? 16 grams. We know that oxygen atomic number is 8, and so the atomic mass is 16. And so since atomic mass or gram atomic mass is equal to 1 mole, so 1 mole of oxygen atom is also equal to 16 grams. Then second, we can see mole of molecule. Similarly, in the case of molecule also, 1 mole of molecules of a substance has a mass equal to the gram molecular mass of the substance. Again, if we take the example of oxygen. So if we take the example of oxygen, oxygen, again, the gram molecular mass is 32. And so this 32 gram is equal to 1 mole of oxygen molecule. Oxygen represents 1 mole of oxygen molecule. So we can say that the symbol of an element represents 1 mole of atoms or molecules of that element. So in order to clear the concept of mole and mass, we can calculate some numericals. Before that, we need to know a formula, that is mass and molar mass formula. Mass is equal to molar mass into number of moles. So in the first example, we can see here, calculate the number of moles present in 64 gram of oxygen. So in this question, we will use this formula, mass into molar mass into number of moles formula. So first, what is the molar mass of oxygen? Molar mass of oxygen. Molar mass of oxygen is 32 gram per mole, because molar mass will be equal to mass divided by number of moles. So we can see that molar mass here is 32 gram per mole. So molar mass is 32 gram per mole. So after dividing mass divided by number of mole, we will get 32. So here oxygen is in natural form, that is molecular oxygen, that is O2. So therefore the number of moles of oxygen will be equal to 64 gram divided by 32 gram per mole. If we cancel them, we will get 2 moles. So the answer will be 2 moles. Then in the second question, we can see, calculate the number of moles present in 108 gram of aluminium. So here we will use a different process. First, we will write the atomic mass of aluminium. So what is the atomic mass of aluminium? Aluminium atomic mass is 27 gram. Gram atomic mass is 27 gram. So since we know that 1 mole of an element is equal to the atomic mass or molecular mass, so the atomic mass or gram atomic mass or gram molecular mass of aluminium is equal to 1 mole. And again, 1 gram of aluminium will be equal to 1 divided by 27 mole of aluminium. And so since we have to find the number of moles in 108 gram of aluminium, so 108 gram of aluminium will be equal to 1 divided by 27 into 108. So if we cancel them, we will get 4 moles of aluminium. So the answer is 4 moles. So after solving all these numericals, we can we can have a clear idea about mole and mass and molar mass. So today I'll discuss till here. Subscribe this channel and click the notification bell. Thank you.